Page 2, let's do this. Looking at 17, first of all, we're dealing with inequalities here. We're going to treat them like equations, but notice the sign's not an equal sign anymore, it's an inequality. But same things are going to apply, like when you have a variable appearing twice on the same side, you're going to combine them. Pay attention to the sign in front. End up with 2x plus 1 greater than or equal to 13. Subtract 1, do the thing, 2x greater than 12, so x is greater than or equal to 6. Now here's what a graph is going to look like. Just like on a number line. Whoops. And the closed circle. At 6. And I want the numbers that are greater than 6. So my graph's going to go towards the bigger numbers like 7, 8, 9, and 10. 18. Solve it like an equation. Divide both sides by -3. X, when you divide by a negative, the symbol will flip. So I get x is greater than -12. Graph-wise, that was a straight line. Fill in circle again at -12, and I want the numbers that are bigger than -12. 19. Notice what's different about this one is you have two inequality symbols going right at you. Basically, you can pretend that this is a three-sided equation, kind of. You're going to choose what you do, and you're going to do it to all three sides. So I'm going to add 4 to all three sides. When the Pac-Mans are chasing each other, like so, you're dealing with what's called an AND problem. That means x, my mystery number, has to be smaller than 10 and at the same time bigger than 6. So it has to be between 6 and 10. Open circles, and the graphs will run into each other. That means my solutions can be anything between 6 and 10. This one's the exact opposite. It's a OR problem. You should already have an idea in your head of what the graph will look like. Solve each of them separately. X is greater than or equal to 12, or over here, subtract 8, get x is less than or equal to 4. Graph-wise, OR graphs will always look the same. They will always be pointing in opposite directions. So you got 12 over here, 4 over here according to the number line. Filled in circles, I want x to be greater than 12. I want x to be less than 4. They can't be both of them at the same time. That's why it's an OR problem. It either has to be less than 4 or greater than 12. Let's take a look. Find a slope of the line that runs through the points 1, 9 and 5, 4. Slope. One definition says that it is according to 2 points, you would subtract the y values on top and subtract the x values on bottom. I'm going to zoom in and do that for you. My 2 points are 1, 9 and 5, 4. The y values, 9 and 4. The x values, 1 and 5. 9 minus 4 is 5. 1 minus 5 is -4. Let's take a look. Something like -5/4. Boom, shaka, blaka. Let's keep talking about slope. Love slope. Slope is also rise over run. And you thought I'd leave him out, but I'm not. It's Connolly. He's walking downhill, so it's going to be a negative slope. Now, when you're finding slope from a graph, really important to find good points. By good points, I mean points where there's a really good intersection point, like right there. That point, no, bad. This point, good. Because then you can count really clearly and quickly. From this point, you'd go down 3 over 2. A slope of down 3 over 2 is negative 3 over 2. I look at my options. It's right there. Option A. 23. Convert the equation into slope-intercept form. Slope-intercept form. Makes me think of a really popular rock song called Y equals mx plus b. Slope-intercept form, set me free. Now, if I really want to get into y equals mx plus b form, dang it, I'm going to have to get y by itself. I'm going to have to get it so it's y equals. So then the question is, how am I going to take this and eventually get to just y equals? That means my 3x is going to have to move over to the other side. It means I'm going to have to get rid of the 2 so that I just have y by itself. Here's how you get rid of the 3x. You subtract it. What a great idea, Mr. Lortzen. Look what happens. They cancel out on the left side. Nice, that's helpful. 2y equals, I'm going to list negative 3x first, because that's what I do. It makes it look more like slope-intercept form. I still got to get rid of the pesky 2, so I divide by 2. I got to divide everything by 2. Therefore, what I'm dealing with is just y now. Looks like negative 3 over 2x. 8 over 2 is 4. Let's see, do I have a choice where that's one of them? Oh, let's go. Answer D. That's what I'm talking about. Page 2. Done.